Hey everyone, welcome back. You ready for another deep dive?
Always.
Today, we're tackling a real head-scratcher in the world of physics. It's a tiny little thing called the X17 particle, but don't let its size fool you.
No kidding. This thing's been causing quite a stir for a decade now.
Exactly. If it's real, it could completely change how we understand the universe, like rewrite the physics textbooks kind of stuff. And we're going to dig into all of it using this fascinating article I found.
Yeah, I took a look at that one too, and it's a wild ride.
So let's jump in. Now, this whole X17 thing started back in 2016 with a group of physicists over in Hungary at the Atomiki Institute.
Right, they were doing what seemed like a pretty routine experiment, bombarding beryllium with protons, basic particle physics stuff.
Yeah, trying to understand how these particles interact, right?
Totally. Except the results they got back, not so basic.
Ah, the good old unexpected result. That's where the fun starts in science.
Yeah, so they were looking at the angles at which electron-positron pairs were emitted from the beryllium atoms.
Okay, so imagine two tiny beams of light shooting out in completely random, unexpected directions.
Pretty much. The angles just didn't line up with any of the known laws of physics. Something was off.
And I bet they double-checked their equipment, ran the experiment a million times, the whole 9 yards.
Oh, absolutely. They were meticulous. And that's what makes this even more intriguing. Their data was statistically rock solid.
Like, no chance this was just a fluke.
They calculated a statistical significance of 6.8 sigma. To put that into perspective, imagine flipping a coin and getting heads 68 times in a row. The odds of that happening by chance are ridiculously low, like practically impossible.
Wow, so something significant was definitely going on.
Yeah.
So what did they think was causing this weird behavior?
They proposed that a brand new particle, which they named X17, was responsible. They even estimated its mass to be around 17 mega electron volts, MeV for short.
Okay, a new particle. But why is that such a big deal? Why is everyone so excited about X17?
Because this particle, if it exists, doesn't fit into our current understanding of the universe. It doesn't behave according to the standard model of particle physics.
The standard model. That's like our best current theory of how all the fundamental forces and particles interact, right?
Exactly. It's been incredibly successful at explaining a ton of phenomena in the universe, but X17 just doesn't fit. It suggests that there might be a fifth force of nature at play.
Wait a minute. Fifth force. I thought we only had four, like gravity, electromagnetism, and the two nuclear forces.
That's what we thought. But this X17 particle, it throws a wrench into the whole thing. It's like finding a missing piece of a puzzle that doesn't quite fit anywhere, making you question the entire picture.
So needless to say, this caused a huge ripple through the scientific community. What was the reaction like when they announced this?
As you might imagine, there was a lot of skepticism. I mean, a fifth force, that's a pretty bold claim.
Yeah, I bet some eyebrows were raised.
Oh, definitely. A lot of physicists were like, hold on, we've been studying this energy range for years, and we haven't seen anything like this before.
That's a fair point. If this particle existed, wouldn't we have detected it already?
You'd think so. Plus, the Atomiki Institute, well, they had a history of reporting anomalies that later turned out to be nothing.
So people were hesitant to jump on the X17 bandwagon right away.
Exactly. It's healthy skepticism, That's how science works. You don't just accept a groundbreaking claim without rigorous scrutiny.
So what happened next? Did the Hungarian team just give up?
Not at all. In 2019, they actually reported even more evidence supporting X17. This time, they observed similar anomalies in other types of nuclear decays.
So more data backing up their initial findings.
Yep. But there's a caveat here, and it's a big one. This new study wasn't peer-reviewed.
Ah, peer review. That's the process where other scientists in the field check the study for errors, biases, and make sure it's solid, right?
Right. It's a crucial part of the scientific method. It helps ensure the validity of research. And this new study, well, it skipped that whole process.
So it's kind of like a red flag, right?
Yeah.
Raises some doubts about the reliability of their findings.
Exactly. It made some scientists even more cautious about the whole X17 thing. But then things took another interesting turn.
Oh, really? What happened? Did someone finally replicate their experiment?
Not quite, but hold on. This is where it gets even more interesting.
Okay, I'm on the edge of my seat here.
Some really well-respected theoretical physicists started looking into the X17 data, and guess what? They actually came up with some theoretical frameworks that could accommodate this new particle and a fifth force.
Whoa, so even with all the skepticism and the lack of peer review, some heavy hitters in the field are like, hey, this X17 thing, maybe it's not so crazy after all.
Yeah. And their reasoning was fascinating. They suggested that this X17 particle might only interact very weakly with other particles and might only show up in very specific types of nuclear decays.
Ah, so it's like trying to find a needle in a haystack. If you don't know exactly where to look, you'll never find it.
Exactly. And it explains why we haven't seen it in previous experiments. We just weren't looking in the right place.
So this whole thing, it's like a scientific detective story.
It really is. And of course, once these theoretical ideas started circulating, other labs around the world were like, okay, we got to try and replicate this. We need to see if this X17 is real.
Right. What did they find?
So far, the results have been a bit of a mixed bag. Some experiments have hinted at signals that could be consistent with X17, while others have found nothing at all.
Ah, so we're still in a bit of a limbo.
Yep, the jury is still out on this one. It's a real scientific standoff right now.
So we've got evidence that's both for and against the existence of this X17 particle. What are the main arguments on each side?
Well, on the skeptical side, some physicists have done calculations suggesting that the anomaly observed by the Hungarian team might actually be explainable within the standard model.
Oh, so maybe there's no need for a new particle or a fifth force.
It's possible. Maybe there was an error in their analysis, or maybe there's some subtle effect we haven't accounted for yet that's mimicking the signal of a new particle.
So this X17, it could just be a phantom, a statistical mirage.
It's a possibility. But then on the flip side, there's the fact that multiple labs, not just the Hungarian team, have reported seeing similar anomalies.
That's true. I remember the article mentioned a group in Switzerland that tried to replicate the experiment.
Yeah, that was the Na64 collaboration at CERN. Their data was inconclusive, meaning they didn't find definitive evidence for X17, but they didn't rule it out either.
So it's like adding another piece to the puzzle, but we're still missing the big picture.
Exactly, and that's the exciting part. We're right on the edge of potentially discovering something truly groundbreaking.
Even if this X17 particle turns out to be a dead end, this whole journey has been pretty incredible for science, hasn't it?
Absolutely. It's a perfect example of how science should work. An unexpected result leads to questions, investigation, debate, and more research.
And through that process, we refine our understanding of the universe, even if the initial hypothesis turns out to be incorrect.
Totally. We're constantly learning and refining our knowledge. Who knows, maybe this X17 saga will lead to other discoveries down the line, even if it's not the fifth force we were hoping for.
So let's say, for the sake of argument, that X17 is real. What could that mean for our understanding of the universe? Like, what would a fifth force actually do?
Oh man, that's where things get really mind-blowing. A fifth force could revolutionize how we think about everything. It could change our understanding of how galaxies form, how stars evolve, how fundamental particles interact.
Okay, so big cosmic level implications.
Huge. It could even help us solve some of the biggest mysteries in physics.
Like what?
Like dark matter and dark energy. We know they exist, but we have no idea what they are. Maybe this fifth force plays a role there.
That's amazing. So this little X17 particle, it's not so little after all. It's opened up a whole new world of possibilities in physics.
It has. This is definitely a story worth following. Who knows what the future holds? Maybe we're on the brink of a whole new era of physics.
It's kind of humbling, to think that we still have so much to learn about the universe.
Absolutely. And that's what makes science so exciting, right? There's always something new to discover.
Well, on that note, I think we've done our deep dive for today.
Yeah, that was intense.
I'm going to be thinking about that X17 particle all week now. Thanks for joining me, and we'll catch you all next time for another deep dive.
See you then.
Bye, everyone.